In the realm of audio production, the mastering process plays a pivotal role in shaping the final sonic experience, ensuring a cohesive and polished presentation of the artist's work. Among the array of tools employed by mastering engineers, real-time spectrum analyzers stand out as indispensable instruments for achieving sonic balance and clarity. These graphical representations of the frequency content within an audio signal provide invaluable insights into the distribution of energy across the spectrum, enabling engineers to make informed decisions regarding equalization, dynamic range control, and overall tonal balance.
The following is a broad description of a mastering tool used by mastering engineer Edward Vinatea of EV Sonic Lab and through his esoteric technical point of view. Subscribe to this channel to receive notifications and like this video to expand and elaborate more on this particular audio subject. Without further ado, let's get to it. Have you ever pondered over how mastering engineers mold the ultimate auditory impression of your beloved music tracks? It's an expedition of precise adjustments and attentive listening, all with the goal of producing a sound that genuinely connects. The unsung hero of this procedure is the mastering stage, where the magnificence of an artist's work is refined to perfection. What method is adopted for this? This is where the real-time spectrum analyzer comes in, a crucial instrument in the mastering engineer's toolkit. This isn't simply a high-tech device, it's a window into the frequency content of an audio signal. It's akin to having a sonic landscapes map, displaying the energy distribution across the spectrum. This priceless knowledge enables engineers to make educated decisions, assisting them in the art of equalization and dynamic range control. Within the vast cosmos of music, each genre presents distinct auditory challenges. Whether it's the forceful bass in pop and rock or the intricate subtleties in jazz and classical music, mastering engineers lean on spectrum analyzers to traverse these varied auditory terrains. For instance, in bass-heavy genres, the analyzer aids in ensuring a powerful low end without blurring the overall sound. In more delicate genres, it aids in carving out a space for each individual instrument, maintaining their unique identities without interference. The secret to unleashing the potential of the real-time spectrum analyzer lies in comprehending the relationship between frequency curves and the visual display. Each peak and valley in the spectrum represents a specific frequency range. The amplitude of these peaks and valleys narrates the story of their prominence within the signal. This visual language enables engineers to identify areas of excess or deficiency in the frequency balance, permitting them to make exact adjustments using equalization tools. However, the analyzer's role extends beyond equalization. It's also pivotal in optimizing dynamic range control. By monitoring the peak levels across the spectrum, engineers can avoid distortion and clipping while conserving the overall dynamic range of the recording. So, the real-time spectrum analyzer isn't merely a tool, it's the mastering engineer's auditory compass, directing them towards the ideal balance and lucidity. It's the unsung hero that guarantees your favorite tracks always strike the correct note. Now let's dive into the role of spectrum analyzers across different music genres. In the world of pop, rock, and electronic music, bass frequencies often take center stage. Here, spectrum analyzers come to the rescue by assisting in sculpting a robust and impactful low end. These tools help mastering engineers ensure that the bass doesn't overshadow the clarity of the mix or muddy the overall sound. They provide a visual guide for the distribution of energy across the frequency spectrum, enabling informed decisions about where to boost or cut frequencies to achieve the desired punchiness without sacrificing other elements of the mix. On the other end of the spectrum, we have genres like jazz, classical, and acoustic music where the devil is truly in the details. In these styles, subtle nuances and delicate balances are of utmost importance. Individual instruments must each occupy their own frequency space without masking or interfering with each other. Spectrum analyzers prove invaluable in this context by offering a clear visual representation of the frequency distribution, enabling engineers to identify and resolve any potential frequency conflicts. For instance, a cello and a piano might both occupy similar frequency ranges. Without careful handling, these instruments could end up clashing, resulting in a less clear and less satisfying listening experience. Through the lens of a spectrum analyzer, however, engineers can spot these issues in real time and take corrective action, ensuring that each instrument shines in its own right. In essence, spectrum analyzers serve as a sort of sonic map, guiding engineers through the complex terrain of frequency balance. They illuminate the path to a well-balanced mix, where all elements coexist harmoniously, each contributing to the overall sonic experience without overpowering or detracting from the others. Whether it's managing the booming bass of a rock track or preserving the delicate nuances of a classical piece, spectrum analyzers are instrumental in navigating the unique sonic challenges of each music genre. By offering real-time insights into the frequency content of audio signals, they empower engineers to make informed decisions and achieve the desired sonic balance. Clearly, the real-time spectrum analyzer is a master of all trades, adept in handling the challenges each music genre presents. How does one read the language of the real-time spectrum analyzer? This question is paramount to mastering engineers who rely on these tools to shape the sonic landscape of an audio signal. Let's delve into the intricate relationship between frequency curves and the visual display presented by the analyzer. The real-time spectrum analyzer offers a graphical representation of the audio signal, with frequency on the horizontal axis and amplitude on the vertical axis. Each peak and valley you see represents a different frequency range, and the height of these peaks and valleys indicates the relative prominence of those frequencies within the signal. So, how does this translate into actionable information for the engineer? Imagine a mountain range on the display, with the tallest peaks representing the most prominent frequencies. These peaks could be the booming bass in a rock track, or the soaring vocals in a pop song. Conversely, the valleys or dips indicate less prominent frequencies, perhaps the subtle harmonics of a guitar or the quiet rustle of a snare drum. The engineer's task is to interpret these visual cues, identifying areas of excess or deficiency in the frequency balance. By doing so, they can pinpoint where the audio signal may be too rich or too sparse and make targeted adjustments using equalization tools. For instance, a cluster of tall peaks in the low-mid frequencies might signify a mix that sounds boomy or muddy. The engineer could then employ a low-mid shelving EQ to selectively attenuate these frequencies, restoring clarity and balance to the mix. On the other hand, a lack of peaks in the high frequencies may result in a dull or lifeless sound. A high-frequency boost could effectively brighten the mix, enhancing the presence and sparkle of high-pitched instruments. This process of interpretation and adjustment is a delicate dance, requiring a keen ear and a deep understanding of the visual language of the spectrum analyzer. It's a critical part of the mastering process that can make the difference between a good mix and a great one. With the real-time spectrum analyzer, mastering engineers can visually decode the sonic DNA of an audio signal. This is the power and beauty of mastering with the aid of a real-time spectrum analyzer. Beyond equalization, the real-time spectrum analyzer plays another crucial role. It's not just about tonal balance, it's also about controlling the dynamic range. This is where the real-time spectrum analyzer steps into the spotlight, providing an essential service in the mastering process. Dynamic range, in essence, is the difference between the loudest and quietest parts of an audio track. It's what gives a piece its sense of depth, space, and overall sonic impact. In the audio world, it's often compared to the contrast in a photograph. Too little, and the image appears flat and dull. Too much, and it can be harsh and overpowering. The same principles apply to sound. The real-time spectrum analyzer aids in optimizing this dynamic range control. It does so by allowing engineers to monitor peak levels across the frequency spectrum. This is key to avoiding distortion or clipping, which can occur when the signal exceeds the maximum level that a system can handle. By keeping an eye on these peak levels, engineers can ensure that the loudest parts of the track don't push into the red zone and cause unwanted distortion. But it's not just about preventing distortion. Preserving the overall dynamic range of the recording is equally important. This is especially true in genres like electronic and dance music, where high energy levels and aggressive dynamics are common. The real-time spectrum analyzer allows mastering engineers to strike a balance, ensuring that the dynamics are powerful and impactful, but not so aggressive that they compromise the integrity of the sound. The spectrum analyzer in this context is like a watchful guardian, alert to any potential threats to the dynamic range. It enables engineers to make precise adjustments, ensuring that each note, each beat, each breath of the music has its rightful place in the sonic landscape. So, whether it's taming unruly peaks or boosting the quieter moments to create a fuller, richer sound, the real-time spectrum analyzer provides the insights and control needed to shape the dynamic range to perfection. When it comes to maintaining the perfect dynamic range, the real-time spectrum analyzer is the engineer's trusted ally. So, why are real-time spectrum analyzers a staple in every mastering engineer's toolkit? It's because these tools are absolutely essential in shaping the final sonic experience of any piece of music. They provide a graphical representation of the frequency content within an audio signal, giving engineers the ability to visually dissect the distribution of energy across the spectrum. This insight is invaluable when making informed decisions regarding equalization, dynamic range control, and overall tonal balance. These analyzers are versatile, proving their worth in a variety of music genres, each with its own unique sonic characteristics. In the realms of pop, rock, and electronic music, where bass frequencies often take center stage, spectrum analyzers assist in sculpting a powerful and clear low end. In more nuanced genres like jazz, classical, and acoustic music, these tools ensure individual instruments shine in their own frequency spaces without overshadowing each other. Mastering engineers must cultivate a deep understanding of the relationship between frequency curves and the visual display of the analyzer. Each peak and valley in the spectrum represents a specific frequency range, and the amplitude of these peaks and valleys indicates the relative prominence of those frequencies within the signal. This understanding allows engineers to identify areas of excess or deficiency in the frequency balance and make targeted adjustments using equalization tools. Moreover, spectrum analyzers are instrumental in optimizing dynamic range control. By keeping an eye on the peak levels across the frequency spectrum, engineers can prevent distortion or clipping while preserving the overall dynamic range of the recording. This is particularly vital in genres like electronic and dance music, where high energy levels and aggressive dynamics are the norm. In the hands of a skilled mastering engineer, the real-time spectrum analyzer is the key to unlocking the full sonic potential of a recording across all music genres. With its ability to visually represent the frequency content of an audio signal, it provides the necessary insights to shape a cohesive and polished presentation of the artist's work. It truly is an indispensable tool in the realm of audio mastering. In our next video about spectrum analyzers, Edward himself will explain in more simple terms some of the most important reasons why spectrum analyzers are considered to be the audio engineer's best secret weapon. Thank you for watching, and please subscribe to the EV Sonic Lab channel.